Hi everyone, Ernie Tech here. This is part two of the Hercules using MTS as the operating system introduction. Yeah, it's an introduction. We're starting out here. We're at part two. We'll be going for a while with MTS. And let's get into this thing here. This is probably the greatest emulator for mainframe operating systems. I know there's one or two other ones out there. Dave Edwards' Sims 390 was wonderful, but it had limitations, of course, because it was primarily geared for Music SP. But Hercules is sort of the one-stop-fits-all Swiss Army knife of emulators for mainframe operating systems, and this is the one that we eventually need to understand the most. So it was created in 1999 by Roger Bowlers, and Roger Bowler. I understand the reasoning is that he wanted a mainframe for his very own, and obviously, like the rest of us mortals, he couldn't afford it, and who can? So he went about making one for himself using emulation, and he wrote a beautiful C suite of software to do just that. Now, interestingly enough, in 2000, our friend Moshix was an editor for Byte Magazine, and he discovered this and utilized it in Linux and was very impressed by it. Was able to write a nice article about it that I have a copy of, or I'll put a link in the description to. And what I wanted to do was to get his permission to include it in this video. So I reached out to him on his Facebook page. He was kind enough to respond, said, "Yep, that was me. Go ahead and use it," and the rest is history. So thank you to Moshix for that. Why do they call it Hercules? Well, I don't know. I'm not sure. Maybe there's a reason that is definite, but my understanding is that Roger Bowler said, well, this has got strength and power like Hercules, so we're going to call it Hercules. All right, next page. Now, I don't want to go into the thing of where I read this to you, because that's silly. We can all read. What I want to do is give you the overview as you're reading it, so you understand what it is I'm trying to lead to. So, obviously, Hercules emulates mainframe hardware. And the mainframe hardware was primarily designed, I guess it was primarily for the IBM operating systems, but other operating systems run on it as well, as long as those operating systems work in an IBM mainframe environment, what they currently called Z. Back in the day, it was S360, S370, S390, ESA, EIEIO. There was no 380, I guess. Then it should work in Hercules. And indeed it does. MTS runs just fine. And there are people out there, and I have access to this, is the ability to use Music SP on it as well. Include and the VM 370 environment as well. MTV, MVT. There's just too many three-letter acronyms for things. So Hercules is the product. It is what you want to learn so that you can explore these operating systems like we're doing here. Now, as we know, it uses files on your PC to emulate or to be a proxy for the actual hardware that you and I can't afford, printers and so on. It uses a file on or several files on your PC to be the storage device, the DASDs that would be humming away in the corner, pulling thousands of amps, I guess, who knows. So the beauty is, of course, you can create this environment on your PC without having to open up the wallet and take a mortgage on the house. There's a couple of files that you should be aware of when you begin to learn about Hercules. The main file that you need to understand is this thing called Hercules.cnf. And what Hercules.cnf is, it's just like in Music SP and Dave Edwards' Sim 390 configuration file. You use a text editor, you put in lines that say what this thing is supposed to emulate, what kind of hardware, what kind of peripherals are going to get hung off of it, where their addresses are, what the unit IDs. You essentially tell this thing what kind of brain it's supposed to have, and it will read that file and it will say, okay, I am now a S370, or I am an ESA 390, or I have this much memory, or I'm doing this, or I'm doing that. You define, you write it in there, as long as it's within the confines of its specification, it will do the trick. Like code. You just have to code it right, and it's just fine. The other thing it uses is something called a .rc file, or a run command file, and under the name hercules.rc. And that is another text file that you just edit with a text editor. and it will let you put in some automation. It will let you automate the startup process, the IPL process, responding to various prompts that it wants from the human. It's going to be your human response. You don't have to have it. You just do everything manually, like I've been generally doing. But if you know how to code this, it will automate the startup process. And finally, there's one other thing that's not so much of a piece of text as much as it's something that you type in as sort of a process, and that is called the automatic operator, which is to say that if Hercules or whatever is sending a message to the console or to the panel, I think it's just to the panel, I'll explain that later, it expects someone to respond. Hey, are you there? Are you down the shore? What are you doing? You can automate the responses by using this automatic operator feature, which is really nifty. I haven't used it yet, but it's there. Now, I'm going to play a video here, and as always, I have to fool around with my OBS Studio. But let me play this video, and then we'll get right back to it. Okay, the first thing we're going to do here is we're going to get an instance MTS up and running using Hercules. And if you haven't downloaded the turnkey, go to my website in the description, and you'll see where to pull down the turnkey MTS-TK file. Unpack it, do all those usual things, put it in a place of your favorite place. Get into a command prompt and just type in MTS, the batch file, to get things up and running. And this is, at least on the right-hand side, is what you're going to see. In my first video about MTS, I showed you how to get the terminal emulation up and running. So that you got to do that as well. So go back and review them if you haven't done so far. Okay, let's get this guy going. IPL 260 IPL sounds like a beer, and press the button. See what happens. All right. Do you want to run the current system? Yes. And a little goes on right here. IPL, otherwise re-IPL now. Just type in OK. And over here, you will see things happening at the same time. Back over here, my initials, and why not? Spell it right. All right, there it is. Now, this is interesting. I was real pleased because one of the comments that I got was from Rupert Lane, and Rupert Lane created the web page that I'm using as my source, as my inspiration for doing this. If without Rupert's web page, trymts.com, I would never have been able to figure this stuff out. It's just that simple. So if you want a really detailed explanation on how to use MTS, go to Rupert's webpage, mts.com. I'll put it in the description. And Rupert was kind enough to remind me, hey, there's a couple things that you can do to make things move along easier. So that was nice. All right, so here we are. And again, remember, you got to be at the right place. Always be at the right place. So over here in our terminal window, we want to go down to the bottom. It's at the bottom that everything happens. So let me scroll down here. All right, peak initialization complete. And once you see where it says peak initialization complete, let me get back on here. Then you start things up a little bit. All right, let's do that here. So the first thing we're going to do is we're going to type in HASP, H-A-S-P. And all right, there you go. So HASP is up and running. Again, scroll down. If there's an easier way to do this, actually, if I recall, Renee Ferlin reminded me there was an easier way to do this, but I forgot. I'll have to review. Yeah, okay. Well, let's just get through this, and then we can deal with that another time. Okay, what I want to do here is type in MTS HSP, get that up and running, which it is. And it's not January the 17th, 2012, but hey, what the heck, right? And then finally, we're going to open up another window right there. Sorry to have everything on top of each other, but for the time being, that's what we're going to have to do. That's going to act as our user interface terminal. This is our console. This is Hercules itself, and so on and so forth. You get it. Back over here, down at the bottom, type in MTS, and then LAS, let out the lines, We did this before, but it's cool. It's cool to watch. And there it is. And then it comes up and says, I'm here. Log in if you want to. I'm not going to log in yet. Just want to minimize these things, get them out of the way, because what the real purpose of doing this is not so much to play with MTS, but the real purpose is to play with Hercules. And if you use your escape key, you'll get over to the, well, what's supposed to look like, I guess, an IBM S370, or in this case an ES390, but we'll just call it what you might see with the blinking lights in front of you, and that is all the register, the program status, word, what buttons you could push, and the things over here in this nice hideous green that I love so much because it's accurate, about all the different pieces of hardware that we've established. So that's probably the most confusing thing that people have to look at when they're playing with Hercules, is what does mostly this mean. This is a little easier to understand, but that is something that we're going to go into now in the rest of this kind of unfortunate slideshow. I don't like slideshows, but sometimes you have to do what you have to do. Okay, so that was fairly easy. It wasn't too painful. Let me get down to the next page here. Up. I always do that. I'm not sure why, but I always do. I always start the video up one more time. Someday I'll stop doing that. Someday I'll figure this out. So what I wanted to show there was just simply, we brought up an instance of Hercules. You have to have an operating system, so MTS is a perfectly great operating system to use. I could have used Music SP, but I haven't spent the time to get Music SP quite right on Hercules. I've got it up and running once or twice, but for whatever reason, it doesn't take me to the starting panel. Anyway, I'm getting aside here. We're going to use MTS as the operating system to make it easier. Way easier, because it's actually a very nice operating system. So that's the hercules.cnf file, just a text file, and you edit it with Notepad, and you're good to go. There might be another file in there, hercules.rc, in CMTS-TK, and that is if you want to have that automation I talked about. But let me talk about this a little tiny bit, because this is all you're going to see inside of that directory. It's very straightforward. You're just going to see these subdirectories, and you're going to see this CNF, and then this batch file that I made that once you get into a command prompt, you just type in MTS and you're off to the races. Nothing more to it than that, thank goodness. The disks are kept inside of a directory called surprise disks. The actual Hercules system itself is kept within a Hercules subdirectory. A lot of stuff in there, but you don't have to get into it. Some nice documentation usually comes with whatever operating system you're using. It may not be just like that. The tape definitions. Unattended. Well, unattended is interesting. So there's two modes for Hercules. One is an unattended mode and one's a console mode. And it just basically, there's a web server in Hercules, and if you want to use the web server, you use a certain mode, and it is I think that's the unattended mode. I've turned it off. I don't like to use the web server, even though it's just fine. I want everything to be old school. So I have the mode set so that everything you do with Hercules is through the what I'm going to show you in a few slides, which is its native window that you see in a command line, in the command world. Keep in mind that when you're looking at Hercules, you're actually looking at something that is utilizing your command prompt window to give a visual representation of what it's doing, its little mainframe environment. So some people are a little confused about what it's doing. Well, it's just using your command prompt. So if you're in DOS, if you're in Linux and you're at a terminal and you start something using a command like a bat file, Hercules is going to come up within that environment, and it's going to take up that command line. You're going to have to start another command box if you want to, but that's how it works. It works inside of, in this case, the DOS environment. Pretty cool. Units are like your printers, things like that. So all this hardware is emulated down deep inside of these subdirectories. It's all there for you to see. Nothing's hidden. It's a very, very kind environment for fooling around and for exploring. All right, so what is this stuff? What happens inside of that CNF file? Well, that's pretty much what it looks like. So there's the MTS file called Hercules.cnf. It can be called, you could call it MTS.rc CNF, but then you would have to tell Hercules to use that instead of the default hercules.cnf. So if you don't tell Hercules as a command line option to use a different configuration file, it will always look for hercules.cnf and use that as the default. So that's what it looks like right here. And this is inside of a DOS window. And what I did, well, not this one, this is actually a notepad window. I changed all the colors to make it look more, I don't know, in line with what we're fooling around with. You know, just sort of in the spirit of, as they say. So let's get into this. Let's actually have a look and see what each of these things do to my best ability to understand. And now that's an important statement. If you're well versed in this, if this is something that is second nature to you and you find that there is something I'm saying which is inaccurate, tell me. I'm not going to have my feelings hurt. I'm not here as, this is not a vanity project. This is here to get things right. And I depend on you guys to keep me on the straight and narrow so that I can learn and that we can all learn in the process. All right, the next page here. Well, actually, let's go back up one page. So this file has sections. One section is the main configuration of the system itself. The next one is for the device definitions, and the next one here is the tapes. And if you notice here, they start off, at least in the case of here, they start off with these unit IDs. And that's how the computer refers to things, unit IDs. And then what kind of piece of hardware it is. And down here, there's the disk itself. But right now, for the next slide, let's have a look at that. So what is this right here? Well, let me go through and kind of tell you how I understand it. So Arch mode, this is actually from an older version of Hercules because this is the one that came with MTS. This has been deprecated. Arch mode is now referred to as, and I'm looking at a configuration file cheat sheet that I put together, is now called Arch level. So Arch mode, Arch level, same thing. Code page has to do with the characters set in ASCII and EBCDIC because that's what we use inside of an IBM computer. We don't use ASCII necessarily. The CP serial, just kind of leave that alone, but there is a logic to this, and it has to do with whether we're using it in what they call basic mode, meaning that you're just on your own doing your thing, it's basic, or whether this is part of an LPAR, something bigger, a cooperation of computers working on projects and things together. I don't know that you can use Hercules as part of an LPAR. I guess you can. I don't know enough about it yet. We'll learn that stuff later as we get into the IBM only world. The CPU models are 3090. The user version is FF. FD, I think, works as well. FF is what's specified, and there is a reason for that, but I will tell you right now, it's a little over my head, so I ain't getting into it. Main size of the memory, this is not memory for, like, you know, what's on the drives or tapes or things like that. That's the internal memory is 128K. Remember, we're talking about something that's back from the 60s and early 70s, mostly. CPUs and Mac CPUs, you can specify more than one CPU. You can specify 2, 3, 4, whatever the case may be that your hardware can handle. You don't have to. It really is a question of, this was stuff that was done way back when PCs were not, well, they were powerful for their time, but not compared to now. If you put in Mac CPU 10 and no process is requiring more than one, then it's not going to use the other 9. If you put in Mac CPU, num CPU 1, then it means only one of those 10 are going to ever get used. That's how I understand it. The system epoch, starting at the turn of the century. Now, if you were emulating a System 360, your epoch would start at 1960. Pretty cool, huh? And then the time zone offset, for me, it should have been -5, but we're at GMT. And, well, we're over there in Greenwich. Now, I've been to Greenwich several times. I live over here on the East Coast of the U.S., but I've been to Greenwich on many occasions in my travels, and one of the fun things to do if you're there is you stand with your feet over the date line, or not the date line, the zero meridian, and you put your left foot on one side and your right foot on the other side, and they actually sell socks in the gift store. This is fun. They sell socks in the gift store that say left and right on your feet. And I've seen people take their shoes off, put the socks on, and stand with one foot on the left and one foot on the east, and it's great fun. Boy, did I go off on a tangent there, huh? Expanded memory size. We have no expanded memory to use. You could if you had more memory, but you're not using it. The console port will be 3270. It doesn't have to be, but you would have to tell your instance of WC320, your terminal emulator, to use a different port. I'm happy with just leaving it the way it is. And OS Tailor Quiet. So I did a little research on that, and as I understand this, what it means is that you can tell Hercules what operating system it's using, and it will then tailor its responses, its error messages, its inquiry, whatever it's talking to you, whatever it's saying, it's tailored to that environment. But if you are using, let's say in this case, MTS, which is not one of the listed operating systems, you're asking Hercules not to say anything. They don't give me any messages about the operating system or whatever the case is, just kind of like be quiet. So that's how I understand it. That's all that was really needed for MTS. There's an awful lot of options here, but for this purpose, they only needed this short number here. Cool, huh? All right, the device definitions. Again, we're talking about MTS, Michigan Terminal Systems. We're not talking about Music SP, and we're not talking about MVS 3.8. We're talking about MTS. The definitions are fairly straightforward. It's going to be the consoles, the remote login terminals, TSOs as they would call them in another operating world. What unit numbers they are. I had mentioned before in the first video that you don't have to specify 1 through 7. All you have to do is just say 0, 1.7, and that will be 7. There'll be 7 instances, as it says DS01 through 7, so that makes it a little easier to type it in. The consoles, there's a different console here, 1052 console, which I think is like a typewriter, and 3270, which is your terminal emulator that you're going to use on your PC. Printers, readers and punch card readers, like the old 80 column IBM cards after the Hollerith cards. If you have one, I wouldn't mind having one in the basement. I wouldn't want to turn it on, have the lights dim and the neighbors call the cops, but yeah, it would be cool to have. And then the 1403 and all sorts of stuff. This is the hardware hanging off of Hercules that you're emulating in some way or form. Now, in MTS, the last version, maybe Rupert can answer this for me. He may have on his website, but maybe just as a reminder. The last version that was made available was D.6.0. But there was a D.6.0A created which was optimized for the Hercules environment. And as part of that, you didn't need to have each tape AWS file or its tape equivalent is what it is, specified, that it was pretty much taken care of for you. So you could opt to have these commented out, but they weren't. And no problem, no foul. It's not giving me any errors, but apparently you don't have to have all these tapes specified. That's the nature of the A suffix in this version. I hope I got that right. I guess this is sort of the most interesting one, only in the regards of this is where you IPL from, or where you boot the system from, and that is a disk. It's a 3380 disk. Now, there's a whole bunch of different versions of the 3380, the models that have different levels of storage capacity, and usually, as I understand it, they're in a collection. You could have 6 or 8 together. I'm not too sure that there's one on its own, but there might be. But the 3380 is the definition. That's the machine that they're emulating here, and it's going to be at unit 0260, which is the base address. Interestingly, that is always the base address of where the IPL starts, and you'll see it in different things, like in Music SP, same thing. I think that was 201, and so on. So that's the base address, the IPL address when the time comes. The SF equals disk. The next one over here is what's the best way to explain it? Sort of a backout file. So you can sort of backtrack some things that you may have done because this is shadowing the original disk, almost like an emergency backup. I don't know. I don't really care about it. It's not important, but that was an interesting feature, I guess. So that is actually there, and that's out there. So if you look at the disk subdirectory of the directory, you'll see that this is actually sitting there as well. But this is the main disk. So this actual file which if you used a hex editor, you could actually go in and look at. I'm not too sure what you'll see, but you could open it up in a hex editor and it would be just there. That's the actual DASD that it uses. Now, when we get to Hercules, you're going to see two screens. You're going to have a screen which is like this, and all that is right here is it's for you to interact with Hercules and for Hercules to tell you things. And the kinds of things that you can do to interact with Hercules is that you can begin the shutdown process, you can initialize Jess 2, Jess 3, whatever you're using. You can shut things down. You have control over the mainframe environment through Hercules as though you were there in the real world. I don't want to get into the details in this video because it's a surface video. It's an introductory thing. But I do want to get into it pretty good in the next couple of videos because it's important. If you're going to be doing if you're going to use Hercules as your emulating environment and you want to play with other operating systems, you need to know enough to, you need to know. Okay. That's one way of seeing Hercules. But if you have this up and running and you press the escape key, then you actually will then see this. And what this is, it is a virtual representation of that big old honking machine that you've seen in so many pictures of the person sitting in front of it, pushing buttons and turning dials and things like that. And it is the console. It is the console that tells the operator what is going on in the machine and lets the operator make changes or stop things or start things or whatever the case may be. And there's a great introductory to that on the cbttape.org. I'll include that in the description. I didn't put it on the last slide. But it says essentially Introduction to the S370 Principles of Operation. And it goes through excruciating detail about what this is and what these mean and what they do. And in a very short intro, we talked about the program status word in Music SP. And each one of these positions in the program status word is important. It is whatever that is reporting can be looked up and then you can interpret it. What does it mean? What is it saying? Why is it stopped? Why is it started? Where is it at? What is it doing? That's the program status word, hence the PSW. Each of these are registers which will then have various values based upon what the machine is doing. It's got general purpose registers. Let's see now. Control registers. You have the address that you are at in the process, the data at the address. The operator can walk through that one at a time if they need to. I'm not sure we can, but maybe there's a way. There were the buttons back in when they had this. You could start it, your IPL, power it off, reset it, store something in memory, all sorts of stuff. Now, right down here, there's only one processor. We only specified one. If you go back and you look at where I said that we only have max num and num of CPUs, there's only one, and that's the one that's running right now. Over here on the peripherals are exactly what is in the list that you created in the configuration file. So it's all the different consoles, it's all the different printers and tapes and all the different kinds of things that make this system what it is. That's kind of it. So that is everything I think that we should talk about in this video so that we don't get overwhelmed, and also so that I have more time to dig in as much as I can into this. Those are two places to go to. I'll also include a couple of extra things in the couple extra links in the comments or the description that tell you how to get into this even more. And in the next video, we'll get into MTS in the environment deeper, but I think this is a good start. All right, please subscribe if you haven't done so already. Keep the comments going. Keep me on the straight and narrow. Correct me if I'm off on a tangent or I have no idea what I'm talking about. And I'll talk to you later. All righty. Bye for now.